Now, still talking about fractions. All these things are fractions stuff, but the next thing we're talking about is proportions. Proportions basically means that two ratios or rates, either one, are equivalent. An equivalent means equal. They're the same. So there's always an equal sign, and what's on one side of the equal sign, say on the left side, has to be exactly equal to what's on the right side. So if I have $20 to 4 hours, and it equals $40 to 8 hours. Now, this is a rate because our units are different. How do I know if this is a proportion or not? Well, I have to reduce both of these, and if they come out the same on both sides, then it's a proportion. So 4 goes into itself once and into 25 times. 8 goes into itself once and into 45 times. So now I've got $5 to 1 hour equals $5 to 1 hour. So this is a proportion, okay? So whenever I have something that I've been told is a proportion, first of all, it's got to have an equal sign, and then I need to check to see if it's true or not. Okay, if they equal each other, then it is a proportion. If they do not equal each other, it is not a proportion. It's just one fraction on one side and another fraction on the other side. So I look at this one, 5/9 equals 18/27. Well, 5/9 is already in lowest terms. If I look at 18 and 27, 9 can go into each of these. So 9 goes into 18 twice and into 27 3 times. So now what I have, is 5/9 equals 2/3. But these are not equal. So it is not a proportion. Okay, they have to be equal in order for it to be a proportion. Let's look at another one. If I have 16/12 equals 28/21, is this a proportion? I don't know. Let me see about reducing each side. So 4 goes into 16 4 times and into 12 3 times. And let's see, 7 goes into 28 4 times and into 7 goes into 21 3 times. So now what I have is 4/3 equals 4/3. This is equivalent. They are equal to each other. So it is a proportion. That's really all proportion means, guys, is that is it equal on both sides? It's comparing two ratios or rates, and they have to be equal to each other. Now, there is another way that we can check this out, and because we have one fraction on one side and another fraction on another, we can do what's called cross multiplying. Okay, so I can multiply these two and see if it equals if I multiply these two. Okay, so let's first multiply the 2 times the 10. When I multiply 2 times 10, I get 20. And it equals, and now let's multiply the 5 times 4, and I get 20, and they are equal, so this is a proportion. In other words, this method isn't just reducing each side, it's called cross multiplying, and you can only do that when you've got just one fraction on one side and one fraction on the other. And all we're doing is doing this just to see if these are proportions or not. Okay, if they come out to be exactly the same, oops, that's the one I just did. If they come out to be exactly the same, then it is a proportion. Let's look at this one. 2 1/3 to 3 1/3 equals 9 to 16. Well, this is, I'm going to take each of, if I'm going to multiply this out, this times this, so 2 1/3, that's 2 times 3 is 6 and 1 is 7/3 times 16. Okay, well, nothing I can cross cancel, so I get, what's 16 times 7? 42. So I get 112/3. And now let's multiply 3 1/3 and 9. So 3 times 3 is 9 and 1 is 10. And our denominator stays the same, times 9. Well, here 3 can go into itself once and into 9 3 times. And so I get 30/1. Okay? So what I have here is 112/3 equals 30. Well, these are not equivalent at all, so this is not a proportion. Okay? They are not equivalent. Now, we use this stuff to find answers in algebraic problems. Oops. Okay, if I don't know what the x is, then I'm going to cross multiply these. So 5 times x is 5x, and that equals 3 times 40 is 120. That's 3 times 4 is 12, and then I just add the 0. Now, in order to get the x all by itself, I need to divide, because 5 and x next to each other like this is multiplying. So that's 5 times x. So the opposite of multiplying is dividing. So I'm going to divide the 5x by 5 to get the x by itself. If I do that on one side, I have to do it on the other. So here I've got x equals, and 5 goes into 120 24 times. So now I've just figured out what my x is. Okay, if I have something like 16 over x equals 20ths, and I want to find out what the x is, reduce this thing first, guys. Always, always reduce. It will make your life so much easier. So it looks like 4 will go into 32 and into this. Okay, so now 8 times x is 8x, and 16 times 5 is 30, so 80. I need to get the x by itself, so I divide by 8. If I do that on one side, I have to do it on the other, and I get x equals 10. Okay? Now, all right, so I have this applied problem, a word problem, you know it as, but we will call them applied problems because that's what they are. So if 2 pounds of fertilizer will cover 50 square feet of garden, how many pounds of fertilizer are needed for 225 square feet of garden? So first of all, I need to set up my proportion, okay? So if 2 pounds, so 2, and this is going to be my pounds. If I could just write it here, pounds of fertilizer will cover 50 square feet. Now, the thing is, it doesn't matter in actuality if I flip these or put them this way. But it's always best, I think, to take whatever the first number is and put it on top, and the second number and put it on the bottom. It just seems to work the best. But what you do need to do is pounds then needs to go over here. Whatever is here needs to go in the top, and whatever's here needs to go in the bottom, okay? So it says how many pounds, well, that's going to be X because I don't know, of fertilizer are needed for 225 square feet of garden. So now I've got my equation. So let's multiply this out. 50 times X is 50X, and 225 is 450. 200 times 2 is 400, and 25 times 2 is 50. And now in order to get the X by itself, I need to divide by 50. Okay, and that leaves me 51, 52, 53, 54, 9. So for this 9 pounds of fertilizer, are needed needed to cover, well, that was weird, to cover 225 square feet of garden. And we've just figured out the answer to our question. All right, so let's look at one more. In one state, 3 out of 5 college students receive financial aid. At this rate, how many of the 4,500 students at Central Community College receive financial aid? So first we need to set this up. 3 out of 5. Now I need to understand what exactly is going to be in the top and what's in the bottom. They're both students, right? But these students receive financial aid, and these students are just students. They don't, okay? So these are the ones with, and these are the ones without in the denominator, okay? So 3 out of 5 students receive financial aid. At this rate, understand that word now, how many of the 4,500 students, so 4,500 is the total amount of students, and again, I need to know financial aid, so make sure that financial aid is here in the numerator, financial aid is over here in the numerator, and that just the total amount of students is in the denominators. As long as your numerators and denominators are the same units, you're fine. So 5 times X is 5X equals, what's 45 times 3? 15, 12, 13. So 135 and 2 zeros. Okay. And X equals, let me do it this way. I need to divide by 5. And so X equals, 5 goes into 13 twice, 7. So we have here then 2,700 students receive financial aid at Central Community College. All right, now you get to try.